Hello viewers, welcome to my channel. Today we shall be looking at the topic factorization of algebraic expression. As we know, algebra is the branch of mathematics that deals with the use of numbers and letters together. When you look at the questions we have on the board from number 1 to number 5, these questions comprises of numbers and letters put together. They are in the class of algebra. We call it an expression when it has no equal sign in it. Like in the case of number 1, here we have a 6x plus 4y. This is an expression. But when you have it in this form, 6x plus 4y, that is when an equal sign is introduced. Let's say equal to 0 or equal to 1 or equal to any number. That is to say equal to 0 here. You call it an equation. This is an expression with that equal sign. This becomes an equation because it has an equal sign in it. So in this sense, we can call this an algebraic expression, while this one will be referred to as the algebraic equation. All right, so in today's class, we shall be looking at the factorization of algebraic expressions. As you can see, the expressions we have here, we're going to be factorizing them. The opposite of factorization is expansion, of which we're going to be seeing this in our subsequent videos. So this is more of a foundational class where we're going to discuss the primary aspect of factorization, which will lead us to be able to understand the bigger topics that we'll be discussing in our subsequent videos regarding factorization of quadratic expression or factorization of quadratic equation, and so many other kinds of polynomials. So in this class, we're going to be talking about the simpler aspect of them, which will give rise to understanding the bigger aspect of them. Please don't forget to click on the subscribe button to be able to get the notifications of other videos that we posted in this channel. Right. Now let's get started. Solution number 1. Solutions. Number 1, we have 6x plus 4y. We are meant to factorize this expression. What do we do first? You should have the knowledge of finding the HCF of the terms that are involved in that expression. HCF, which means highest common factors. Highest common factors. So we have to get the HCF. The simplest way of understanding this, the first thing you do is to know the highest common factors the expressions involved in that particular question has. All right, so now look at what we're going to do here. To get the HCF of the two of them, look at what I'm going to do. That is the HCF of 6x and 4y. And how do we get the HCF of two terms? We have to look for number that divide both expressions or both terms without remainder. Which number can divide 6 and 4 without remainder? Of course, the number is 2. 2 divided 6x will give us 3x. 2 divided 4y will give us 2y. It's just like saying 6x divided by 2. 2 cancel this one will give us 3. That will now become 3x as we have it. Likewise, this one. What else can divide? No number can divide 3 and 2 without remainder. No number. Now, the next thing we're going to look at, is there any other thing that they have in common? In this case now, there is nothing in common between these two terms here. So that is to say, the HCF of 6x and 4y is 2. So in factorizing this, what you do is to write the HCF outside of the bracket. And what do you do next? The simplest, that's the last point of your dissolving this into HCF. And that's what we have there is 3x and 2y. So you will simply insert them inside the bracket. That will now be 3x, then plus 2y. So this becomes the solution to this particular question. So to factorize two, terms in an expression, or three terms in an expression, the first thing you have to do is to find the HCF of each terms that are involved in that particular question. And when you do that, you get the HCF written outside of the bracket. Open your bracket and write the last point of the numbers you have there. And that gives us the answer to this question. So the factorization of 6x plus 4y will give us what? 2 bracket 3x plus 2y. And when we open this bracket now, we'll get this back. Factorize this, you get this. Expand this, you get this. So factorization is the opposite of what? Expansion. So to test this, we have to say 2 times 3x will give us 6x plus 2 times 2y will give us 4y. So that explains the solution of number 1. You can use the similar approach in solving number 2 question here. Can you give it a try? Let's get it done. Question number 2. Question number 2. Here we have 18x minus 24y. Let's get the HCF of the two terms here. That is 18x and 24y. 24y. The HCF. 2 can divide the two numbers here. 2 divide 18 will give us 9x. 2 divide 24y will give us 12y. Can any number divide 9 and 12 without remainder? Yes, of course. 3 can divide 9 and also 3 can divide 12. So we use 3 this time around. 3 divide 9 will give us 3. That's 3x. 3 divide 9x will give us 3x. Then 3 divide 12y will give us 4y. When you look at what we have here, they do not have anything in common. No number can divide 3 and 4 together. No number. And x and y are different alphabets altogether. So when nothing can divide them further, then you take the product of what we have at this side. So therefore, the HCF of this, that's the 18x and 24y, will now be 2 multiplied by 3. The answer is what? 6. So the HCF of 18x minus 24x, that's the 18x and 24x, is what? 6. That is the HCF. So the first thing we do is to write the HCF, open bracket, and write the last terms that we have in resolving this in terms of its HCF. And that is what? 3x minus the next one, 4y. This becomes the result of this factorization. I hope this is getting very interesting. You'll find the HCF. After finding the HCF, you write it outside the bracket, open your bracket, then you write the last point of your dissolving this into HCF. This is exactly how to find the solution to this. Or better still, you can do it this way further. You can still approach it in this format. Then after getting the HCF as 6, you write it, open your bracket, write the same expression you have here, which is 18x minus 24y. Then the next thing you do, that is if you don't want to follow the approach of getting the HCF and writing the last point of the terms you have there. So you now divide each of these by that HCF, and that is 6. Divide each of them by the HCF. So by so doing, we have 6 brackets. Then from here, 6 divide 18 will give us 3. 6 divide 24 will give us 4. So what do we have left in the bracket will now be 3x minus 4y. So that is the result of the factorization of the question, 18x minus 24y. That is the solution for that. Now let's take number 3 question. Number 3 question. I hope this is getting very interesting. You can ask your question in the comment section if there's any area of confusion here. Please don't forget to click on the subscribe button so I'll be able to get other subsequent videos regarding factorization of quadratic expression and quadratic equations. Number 3, here we have 20a minus 12b plus 28c. How do we factorize this? Remember what I did in the previous ones? I will have to get the HCF of 20a, 12b, and 28c. When we do that, let's get the HCF. That's 20a. That's the first one here. 12b, then 28c. Let's get the HCF. 2 can divide all through. 2 divide 20a will give us what? 10a. 2 divide 12b will give us 6b. 2 divide 28c will give us 14c. 2 can still go again. 2 divide 10a will give us 5a. 2 divide 6b will give us 3b. 2 divide 14c will give us 7c. Can any number still divide all the 3 terms here without remainder? Of course not. No number can divide 5, 3, 7 without remainder. And they do not have any alphabet in common in this sense. So therefore, the HCF becomes 2 multiplied by 2, of which it will give us what? 4. So 4 is the HCF of 20A, 12B, and 28C. So what we have to do is to write our HCF first and open a bracket. Then we can write the last term or the last terms that we have in dissolving this HCF. All right, so that is what? 5A minus the next one 3B, then plus 7C. So this becomes the solution for the factorization of 20a minus 12b plus 28c. This is the solution. I hope this is getting very interesting. You can give number 4 a try. Pause the video and give number 4 a try. All right, so let's move to number 4 question. Number 4 question has some powers. I hope you're not getting confused with those powers there. All right, so let's take number 3 example. Number 4 rather. Number 4 example. That is 4a cubed, that's raised to power 3, minus 6a plus 8a squared, that's raised to power 2. So how do we factorize this? Just usual method. We have to get the HCF of each of the terms there. So to do that, it's pretty simple. So we write 4a raised to power 3, 6a, and 8a raised to power 2. So what number can run through? That is 2. 2 divide 4a cubed will give us 4a raised to power 3. Then 2 divide this will give us 3a. Then 2 divide 8a squared will give us 4a squared. What else can divide? No number, sorry, that's a 2 divide 4a cubed will give us 2a cubed here. That should be 2 here. All right, so when we look at these numbers, 2, 3, and 4, no number can divide the 3 of them without remainder. But now the question is, do they have any other thing in common that can divide through? Yes. This one has a raised to power 3, this one has a, this one has a. It has something to do with a all through. So we can use a to reduce it further. So let's use a now. A divide 2a raised to power 3 will give us 2a raised to power 2. It's just like saying 2a raised to power 3 divided by a. What will it give us? It's just like saying 2 multiplied by a multiplied by a multiplied by a. Because a raised to power 3 means a times in each other up to 3 times, then all over a. Then can this one cancel this? We'll now be left with 2 times a will give us 2a squared. Just like what I have here, 2a squared. I hope that is getting interesting. All right. So a divide 3a will give us 3 because a will cancel out a. Then a divide 4a squared will give us 4a. So when you look at this, nothing can divide the three terms further. Nothing can divide them further. So what do? That is to say, we can now go for our HCF. The HCF of this will now be to get the product of what we have here. So HCF will now be 2 multiplied by A will give us 2A. So 2A is the HCF of 4A cubed minus 6A plus 8A raised to power 2. All right, so now to do the factorization, we have to write the HCF first, which is 2A bracket. Then we write the last expressions that we have here. That's the last terms that we have in resolving this into its HCF. And that will now be 2A squared. 2A squared, then minus the next one, 3 plus, then 4A. This is the result of the factorization of this. And when we try to open this bracket, that will give us this back. That is to say, the opposite of factorization is expansion. 2a multiplied 2a squared will give us 4a raised to power 3. Then minus 2a multiplied 3 will give us 6a. Then 2a multiplied 4a will give us 8a squared. So that's how to dissolve this kind of a question. Please don't forget to click on the subscribe button as we continue to post more videos that will be very, very interesting to your learning. All right, so let's get to number 5. Question number 5. You can give it a try. Pause the video and give it a try. Question number 5. For the number 5 question, the question says 4x squared plus 8x. How do we factorize this? The first thing to do is to find the HCF of the two terms that we have here. Of course, we put it this way, 4x squared and 8x. Which number can go through? 2 can divide 4 and can divide 8 altogether. So we use 2 to run it through. 2 divide 4x squared will give us 2x squared. 2 divide 8x will give us 4x. 2 can still go further. 2 divide 2x squared will give us x squared left. Then 2 divide 4x will give us 2x. So can we still divide further? Yes, we can divide further because they still have something in common. They have something to do with x on both sides. So we can use x now to reduce it further. So that will now give us x. Divide x squared will give us single x. X divide 2x will give us 2 here. So to now get the HCF will now be 2 multiplied by 2. We get the product of all of these multiplied by x. That will give us 2 times 2 is 4. 4 times x will give us 4x. So 4x is the HCF of 4x squared and 8x. So to factorize this, we have to write the result of the HCF, which is 4x. 4x, we open the bracket and write the last point of the terms that we have in dissolving this into HCF, and that is x and 2. So we now have it as x plus 2. So this is the result of the factorization of 4x squared plus 8x. I hope this is very interesting. Please don't forget to click on the subscribe button as we continue to post more videos that will be very interesting to you. In our next video, we are going to be talking about factorization of quadratic expression and factorization of quadratic equations. Please click on the subscribe button to support the channel as we continue to make mathematics easy and simple for you. Thank you and have a blessed day.